So to create new Git repository, you can use this command called as git init. And then that will create the Git repository. So git init is the first command that you can execute after installing Git. Then to clone these repositories, you can use Git Clone and then the URL of the repository. It uses the SSH protocol, and to set up the SSH protocol, we're using this protocol. So if you want to clone any repository, for example on the GitHub, have you used GitHub?
Yes.
Yeah, so if you want to download any Git repository, you can use this command called as Git Clone and then the URL of the Git repository. So there are two ways you can download the Git repository. One is using HTTP protocol, you can see here, and another is SSH. So if you want to use HTTPS, you will have to use the user ID password, and if it is SSH, you can set up the SSH key. SSH key is like a password, I mean. So you have to create the SSH key, and once SSH key is there, you can if you create the SSH keys, there are two keys, public and private key. So public key you can put it on the server, for example GitHub server, and private key you have to keep it on your machine, and then you can like connect to the Git repository. So as I said, HTTP and SSH, there are two ways, and here is the command. As you can see, SSH keygen. This is the algorithm RSA, and this is the number of bits that will be used to generate the key. And you can also put optional this thing, the email address of the user. So when you execute this command SSH keygen, what happens is two keys are generated. One is id_rsa.pub and id_rsa. So .pub means public key. You have to upload this public key to the Git server, for example github.com or any other server. And id_rsa, this key you have to put in .ssh directory. So what happens is this private key will be used whenever we have to talk to the GitHub server. So here you can see we can add this public key, adding the public key onto the Git server. So if you go to GitHub, you can see there is one setting called as SSH and GPG keys. So you can upload that your public key there. So if you want to see the Git configuration, you can use these commands. So there are different settings that are used. For example, git config-l. So you can see here username, then user email address, all this Git configuration is there, right? So if you want to view that one, you can use this command git config-l. And it is also showing here, you can see this remote.origin.url and remote.origin.fetch. So you can see the remote repository as well using this command. And if you want to edit anything, you can use this command git config edit. Now there are three configurations: local, global, and system. So if you edit globally, that means those settings will apply to all the repositories. Git config local means only local repository that setting will be applied.
So these are not Git Bash Commands, right?
Yeah, they are Git Bash commands.
Oh.
Yeah, you can use these commands in Git Bash. So these commands are like same for all the Git clients. So you can do the configuration for specific repository using -- local option. -- global means on your machine, like there are a lot of other Git repositories, so all the repositories get impacted using these settings. So this setting will apply to all the repositories. So if you do -- local, then those settings will be like used just for that current repository. Then there is a HTTP generate SSH key. I already told you how you can create the SSH keys. So in every application, you have to use these commands first of all. So like if you join any company, you will have to use this command to create your public key and private key, and then you can give the public key to the DevOps guy to add that into the Git server. Adding files into staging area. So in a Git there is a concept called as a working directory, staging area, and then there is a repository. So changes are committed into the repository after this command git commit. Still then nothing is goes into the repository. So whatever you work, whenever you check out branch or any changes you make, so that happens in the working directory. And if you add that files or the changes using git add command, then that goes into the staging area. Okay, and once it is in the staging area, so if you do git commit, all the files that are in the staging area will get committed. So before committing, you have to put it in the staging area. So you can see there is one file that I changed here, f1.txt, and then there is a git add f1.txt. So we have added the f1.txt to the staging area, and from the staging area it gets committed. So if you do git commit, then that particular file will be committed into the repository. Then checking the git status, like in a git repository, when you are working, you work in a specific branch. So if you want to see what is the status of the branch or the name of the branch, you can use this command git status. You can see here on branch master it is saying, so you know like what branch you are on, and it also tells if there is any untracked files. So here you can see f1.txt file is there, so that is untracked file. So you can basically check like what changes like are done, what files have changed, what files have been untracked. So that way you can get an idea like what changes have been done, and then you can choose specific changes that you have to commit. Then committing changes to the local git repository. You can use this command git commit -m. So whenever you commit, you have to give the message like whatever changes you have done, you have to give that in the message so that other people can know. So the message is logged into the git repository log. So whenever people see the git history, they like see, okay, this commit is done and what changes have been done using this message. So this message is very important. Every time you commit, you have to put that message git commit -m, and then that message. And then git status is there. So whenever you commit everything, git status says everything is up to date, nothing to commit, working directory clean. Now this is another important topic, ignoring files. So ignoring files is basically sometimes you don't want to put all the files in the git repository for the tracking purpose. For example, if you are working on Java, then file is created, like target directory is created, and if you are working on the .NET projects, .bin directory is created where all the execution happens. So you want to track only the source code files, not the execution files like the compiled files. So you can do that using Git Ignore File. So as you can see here, if you are working in IntelliJ IDEA, you want to ignore this file, so you can create .ignore file and then put this content in there. Depending upon your project, this files will be different. Like if it is a Maven project, you want to exclude target and log directly. Sometimes if you want to ignore a specific file extension, for example XML, you want to untrack, then you can do star.xml. So all the XML files will be ignored and that will not be tracked. So viewing the history of the commit, so all the commits happen, and you can see the commits. As you can see here, there are two commits, C1, C2, and if you want to see the log, you can use this command git log, and then it will show the list of all the commits. So in this particular branch, I have got two commits, as you can see, and it will show you the commit ID. So the yellow thing that you are seeing here is the commit ID. And then it also shows like which person or the developer has done that commit, and also the date, and you can see here that commit message at the downside. So that way you can get more information about the changes that have happened in particular Git repository or branch. And there are other options. For example, you want to see last two commits, or you want to see the commits done by specific person, or you want to see the commits that have happened in specific date, or the commit message, you want to search specific commit message. All these options are available. So basically you can search through the commits for anything using this git log command. So if you want to see what's happening for the file in working directory staging area, you can use these commands cat f1.txt. So if you do cat f1.txt, it will show you the that file contents that are in the working directory. Then if you want to see that content of the same file but in the staging area, then you can do this git show :f1.txt. So file is same, but there are different copies. Like the copies, one copy is in working directory, one copy is in the staging area, one copy is in the repository. So all these three copies can have different contents. So you can see the working directory has this content version f1 in working directory. Then in the staging area, this has got cache version of the f1 in the staging area. And then there is a repository version you want to check, git show head :f1.txt. So when you say head, in that commit it will show the contents. And if you want to see the like previous commit, then you can use head this _1 and then f1.txt. So you can basically look at the history of that file as well. So head means the latest whatever is the commit in that repository. It will go and then check what was the file content. So head _1 means previous commit, and if you do 2, then it will go to the previous 2 times, like that. So you can go back like that, and then check the contents of that file, because the file is the same but it can have different contents as we make the changes in the repository. So you can remember this command git show :f1.txt and git show head :f1.txt. Difference between files in the git, you can use this git diff command. So there is a git diff command that you can use, and if you do git diff, what it will do is it will show the differences between staging area and the working tree. If you want to see the differences between the head and the working tree, you can use git diff head. Yeah. So you can remember there are three areas: working tree. So whenever you check out that all the files are in the working tree, whenever you stage something, then this it will go into the index, this stage, and then there is a head, that is the topmost commit or the last commit of the repository. So you can check this Git Diff command and then see like what things have changed as compared to the staging area or the head of the repository. So you can see here Git Diff command is executed, and then there is a diff. It is showing like what files have changed here. So on the command line it doesn't show properly, but if you go to the IntelliJ, then it will show it properly. Git diff catched, Git diff head. Or there is one this below will show how Git K tool looks like. So there is one tool called as Git K. So that tool you can use, which will give you the graphical interface, and that will show you like what changes have happened. Then there is a how to revert last commit in the Git. Now what happens is sometimes you make some changes and commit it to the repository, but you realize that you have done something wrong and you don't want to push that changes to the remote repository or GitHub. Then you can either Git revert it or Git reset it. So if you want to Git revert it, you can use this command Git revert and then commit ID. So if you want to like revert the last commit, then you can use Git revert head. If you want to give, revert the previous commit, then you can use Git revert head, like that. So in this specific example, you can see there is a there are 4 commits, P, Q, R, S, right? And head is at this point. So Git revert head caret we have done here. Git commit M reverting, and then that's how you can revert these commits basically. So there are 2 commands, Git reset and Git revert. So what happens is in reset the commits are deleted. For example, you can see there are 4 commits here, C1, C2, C3, C4. So before reset there were 4 commits, and after reset what happens is the 2 commits are deleted. So that is the difference between reset and revert. In reset the commits are deleted, in revert the commits are not deleted. What happens is another commit is added, and yeah, that's the main difference between reset and revert. So in revert the commits are preserved, so another extra commit will be added, but that will not make any changes in the Git history. It will just add extra commit. Now creating the branches, Git branch and the branch name, that is how you can give the commands. So let's say you are on the master branch and you want to create another branch, say B, then you can use this command git branch X. So what happens is the branch name X is created. So if you want to see the list of all the local branches, you can use command git branch, that's it, and it will show the list of all the branches. You can see there are 3 branches, B1, master and X, that we just created. Then there is a git checkout. So if you want to switch to the branch that you have created, you can use this command git checkout and then branch name. So we are checking out another branch called B2. So you can see we are on the B2 now, and if you want to check out another branch, say X, you can see git checkout X. So all you have to do is just give the branch name and then you will be checked out to that branch. So there are two branches, right? Local repository and remote repository. For example, github.com. So if you want to see the local branches, you can use git branch. If you want to see the remote branches, you can use git branch -r. -r means remote. So remote repository branches will be displayed. So merging can also happen. If you want to create, you have created a branch and you want to merge to the master, you can do it like this. Fast forward merge. So you can see there is a master branch pointing here, and then from the master branch, let us say you create another branch called as some feature, and then added these two commits there. So once it is added, then if you want to merge it, you can merge it like that. So this one, it is showing how you can merge it. So merging is basically we have to club together two branches changes. That's it. Now push and pull. So this is very important. If you have created any changes locally, and then what you have to do is you have to like other person is there, like you in your team, and then that person want to see the changes. So what you have to do is you have to create the pull request. So to create the pull request, first of all you will have to push the changes to the remote repository. So you can see here there is a remote repository here, and then there is a local git repositories. So local git repositories like we use normally when we are working, and remote repository is like on the server. So what you have to do is you have to push the changes. Push means from local machine you are pushing the changes to the remote machine or remote git server, and then you can create a pull request so other people can see the changes. Otherwise other people will not see the changes. You will have to push the changes, and same way once you after you push it, other person will have to pull the changes. So that is how it happens. You push the changes and other person can pull it later on, and once he pulls the changes he can see what changes he have done. So you can use this command git push command to push it to the specific branch. So that's it in this one, git repository. Do you have any specific questions on this one?
No.
So if you do practice, then only you will understand. Like theoretically it is not easy to understand it, but if you practice it, then you will understand. So you can do like creating the project in the GitHub and then cloning the repository. So if you can do that, all those steps, so that will be like homework for you. You can do it later on. So we want to do Selenium and .NET, right? So .NET and Java is pretty similar. You have to in .NET you have to use using system collections. So all these are namespaces, and then you can use new Chrome driver syntax to create the Chrome driver, and then you can give the path of the driver. So in this path you have to put that Chrome driver exe, and then you can use iDriver. So I is actually interface. So this is an interface, and this is the actual class from which we are creating an instance of the driver. And once the driver is available, you can use the methods like navigate or the find element. So Selenium API is pretty simple and straightforward. So do you have any questions on the Selenium, specifically like API related?
No. But yeah, if this one is the latest one, right? So Selenium now latest version. So in that protocol, there, right?
Selenium version keeps on changing. So currently it is 4.0.
Yeah.
Yeah. So the protocol remains the same. There is no much difference. Only thing is that we are able to send the HTTP request to the microservices. So basically we can test the backend as well. So normally we test the front end, but with Selenium 4 we can also test the backend. Yeah, so that is the only difference in the latest version of the Selenium.
And now one more question, Bhaiya. If the browser versions keep on changing,
Yeah.
so where we can do, Bhaiya, that one?
Yeah, so there is a Chrome driver, right? Chrome driver you have to download every time.
So say for example, Chrome driver is 80.
Yeah.
So next time it will be going to be like 80.1, 80.2.
Yes.
So to keep on updating that, so can we write any?
Yeah, so basically to fix this, you can use these browser stack cloud-based solutions.
Oh,
Yeah, so what happens is those when you use the browser stack service, they will take care of the versions.
okay.
Yeah. So if you want to run locally, then you will have to manually download that. So there is no any other way.
Okay.
Yeah. But if you browser stack, then you will not need to do it manually. That is the only thing. So in Selenium, I will tell you some of the important things. You should know how to do the Xpath and Css selectors.
Okay.
Then synchronization is also very important. That so have you used the Spec Flow?
No.
No. Okay, so Spec Flow is actually
C-sharp.
it's a BDD framework. So you can write the tests using BDD format, like in the human readable language.
Okay. No, okay. This one is a keyword driven.
Let me show you what we're testing. So you can see here Spec Flow tutorial is there. Okay, I will send you that link.
So that's a Spec Flow is a different tool.
Yeah, Spec Flow is a BDD framework basically.
Yeah.
So just like Cucumber, right? You know Cucumber. So same way in .NET they call it Spec Flow.
Okay. In Java we use Cucumber.
Yeah, in Java we use Cucumber. In Spec Flow, in .NET we use Spec Flow. So the meaning is same actually. There is no much difference. BDD development. So I will send you that link as well. So it is called as Gherkin language. So if you look at the feature, you will understand. So it's very simple. You can, like anybody can read this and understand what's happening or what we are testing. So you can, these are the keywords, scenario and then scenario name, and then there is a given and then these are the keywords. So anybody can see and like see what we are testing. So a feature can have multiple scenarios, and then there can be a scenario outline. Like if you want to repeat the same thing with different data, then you can do scenario outline. Then there is a grouping the scenarios and features with tags. So you can use the tags. So tags are very important if you want to filter the scenarios. Yeah, so this thing is very easy to understand. Like if you go through this tutorial, you can know. So if you go to softpost.org, that's my website. You can find it in here, development models. And then just go through that. If somebody asks, you can tell them like it is a human readable language, and you can write the test using this syntax: feature, scenario, given, when, then. Yeah, and Spec Flow is basically this thing, and Cucumber is also this thing. Okay, so let us have a look at Xpath and Css Selector. So you should know how to write these Xpaths. Okay. So if you don't know, it will be difficult because you can copy and paste the Xpaths from the Chrome tools, but that is not a recommended way. Like if you want to get the Xpath for this one, you can inspect it and just right click on that element and then copy Xpath. So this is one way, but normally I like to do it manually.
Or we can generate through any tools as well, no, brother?
Yeah, so that
Xpath
is also
generator.
possible. Like Firefox plugin is there,
Oh,
so you can use that one as well. But sometimes you have to write it manually as well, so you should know the syntax, like how to write this one. Yeah, this is very important. So basically you have to give the tag name and then attribute name and then attribute value.
okay.
And there are different variations in which you can write it. So following sibling, preceding sibling, basically they allow you to get the adjacent elements. Sometimes you have to find the element with the text, specific text. So you can use this text method. Sometimes you have to find the element that starts with specific element or text. So these are various functions or syntax they are there. So you need to understand how to use that. Then there is a CSS selector similar to the Xpath, only difference is that syntax is a little bit different, that's it. So here you don't need to use the at symbol, you can just use the attribute is equal to an attribute name or attribute value. Yeah, so that is the only difference, otherwise everything remains same. So syntax wise it is different. Now in the synchronization there are two ways, implicit and explicit. So you should not mix both the both approaches together. So basically if you want to use implicit wait, then you can use implicit wait, but don't use explicit wait then in your code. So you have to choose one of them, and the one that I like is the explicit wait. So I don't use this one. Yeah, so
Also we can save the time.
yeah,
Using it.
so explicit wait I will recommend you use that one, because in implicit wait the problem is that it will wait for 50 seconds. Here we have given, so it is a fixed timeout. With explicit waits you can give like limited timeout, and then it is specific to the element, it will not apply to the all the elements in your application. So that's why I like explicit wait. And then here is actions, like if you want to do like mouse hover action, so there is one actions class that you can use, and then there is one method called as move to element. After that there is a this we have already seen. So that's it. In Selenium it is not very difficult. If you want to like clear the interview, you should know the basics, XPath, CSS selectors and synchronization, so the one that we have just discussed. So if you are clear about those concepts, then I think it will be easy for you to clear the interview. So have you got any questions on the Selenium section?
No.
Yeah, just if you have any questions, let me know later on, because right now if you don't have it, that's fine, but later on you can have questions. So if you do practical coding, then only you will face a lot of issues. Like sometimes what happens is if you try to click the element, it doesn't click it. Or if you want to like, so a lot of things happen, like, so in that scenario what you will do, like click is not working, then what you will do?
Force click we have to do, or that Ajax something.
A JavaScript executor you can use.
JavaScript executor.
Yeah, so that you can use. Yeah, so these things you need to know, and you will get to know these things only when you can do the practice. Okay, so the last section that we are going to cover today is CI server. So you can see there is a section for teamcity, Jenkins, Bamboo. We are just going to see teamcity, but the concepts remain same. So normally what happens is teamcity is a server on which we execute the tests. Okay, so teamcity is a server, CI server. There is GitHub is a Git server, and what happens is teamcity server talks to the GitHub and then asks, okay GitHub, give me the code that you want to build. So when you want to set up a project on teamcity, you have to give the repository URL. So there is a concept called as VCS roots. So VCS is nothing but version control root. So this is the UI, and you can see there is a if when you create a project, you have to create a VCS root. VCS root is nothing but a Git URL. So teamcity supports other as well, but Git is market leader. So nowadays nobody uses other tools, just Git. And then here you have to give the Git URL. You can see here I have given github.com URL. So basically what happens is teamcity goes to the GitHub and then says, okay GitHub, give me this project source code. And then GitHub says, okay, if you give me the SSH key or the user ID password, then I'm happy to give you the code. So once the code is available to the teamcity, it can do anything, like it can build, because teamcity server has got a lot of tools, like if you want to build the .NET project or say Maven project, so it has got all the tools. If it doesn't have tool, then you have to ask the DevOps person, then they can install it for you. And that's it. Once it is there, you can create the build configurations. Build configurations is basically you tell teamcity server, okay teamcity server, here is your source code. Now I will tell you what you have to do with this source code. Sometimes you have to build it, then you have to test it, and there are a lot of things that you can do as well, like you can give the filters, you can tell what report you have to generate, all those things. So you can see here the build steps is very important, and then there is a triggers. So triggers is basically tells teamcity server that when you want to run it. For example, when some changes happen in the repository, you want to trigger it. That is called as VCS trigger. Sometimes you want to run it nightly, then that is called as a schedule trigger. So that thing happens, and then there is a failure conditions parameters. So build steps is one of the important step. Basically what we tell here is what we want to do. For example, if it is a Maven project, then we tell that okay, execute the Maven goal test, and then teamcity happily executes the test. So you can see there are different types of build steps. If it is .NET project, what you have to do is you have to use the .NET process here, like MS build. If it is an IntelliJ, you can see there is an IntelliJ project, there is a Maven project. So there are different tasks or runners that are available there. So basically you have to select that and then tell teamcity to execute that particular action. And build triggers, I already told how you can schedule the triggers. So trigger is basically we tell teamcity at what point we want to execute the tests. And then there is a save artifact thing, like when the execution happens, the reports are generated. So if you want to save the artifact, so that is in the build steps, there will be one setting to save the artifacts. So when the artifacts are saved, you can actually go and then look at the report after the execution happens. Okay, I think that's it in teamcity. So have you worked on any other CI server?
Jenkins.
Okay, so yeah, so it is similar to the Jenkins. all you have to do is just give the build steps, Git repository, then the steps that you want to execute, and then report is generated, so you want to save it on the server. So same thing we are doing in the teamcity as well. Nothing is different, everything is same. It is only that the server is different. It comes from the teamcity company. That's it.